Now let us see how to get this mirror formula. What is mirror formula first of all? Suppose you take a mirror, keep an object at a distant place, and after reflection the rays coming from the object, they meet at a point and form the image. What is the object distance? What is the image distance? If you take another mirror, will the image be formed at the same place? If it is different, why so? Then does it depend on the mirror? Yes. All these things can be connected. And the main criteria involved when you purchase a mirror, suppose you go to a shop, you ask the shopkeeper, give me a mirror, he will ask you, what focal length he will ask. First of all, he will ask you whether you want convex mirror or concave mirror. That is the first question. Then, what is the focal length that you need? So, focal length is the first factor with which we distinguish the mirrors. A mirror of so much focal length, another mirror of this much focal length and all. So, now if you want to get the mirror formula, that the formula which connects focal length, object distance and image distance. Because same object at the same distance, for another mirror of different focal length, image will be at different place. So all these should be connected. That is called mirror formula. And in the beginning itself, I will write what is the formula, because as I do the derivation, of course, you must be ready with pen and paper again. Take a pen and paper, sit in front of the your mobile or whatever the gadget you have. You should keep on writing it. Without writing, don't watch it like as if you watch a movie. Please have a pen and paper and keep on writing. So I will write the formula in the beginning itself. What we are going to get today after the derivation, this is the formula that we are going to get. So a relation which connects object distance u, image distance v and focal length, that is called mirror formula. Okay. Now, if this is the formula that we are in need of, we will take a particular case in a concave mirror. We will take the help of concave mirror. Again, this mirror formula holds good for all the types of mirrors, and you can derive it using convex mirror, you can derive it using concave mirror, and it is applicable everywhere. But we will take the help of concave mirror now. Okay, so you must be ready with your paper. Draw a concave mirror. You know that concave mirror reflects from the inner side and it is painted outside, and let this be the principal axis, right? A concave mirror such that it receives light from the left hand side and it falls on the mirror. The ray of light is given an opportunity to move along the plus x axis, positive x direction. Okay, and this is the pole of the mirror, and this is the focus, the point where parallel rays meet, really meet, not like convex where they appear to diverge. And so concave mirror brings the light to the focus, whereas the convex mirror diverges. And this is a part of a sphere, and that sphere will have a center, C. And you know that this focus is in the middle of center and pole, because distance from pole to focus is called focal length, which is half of the distance from pole to center, what you call radius. Okay, now take an object here, like a candle flame, or symbolically I will represent the object. In order to see whether the image is erect or inverted, I give a arrow to the top. I will call it as a flame. This is the flame part, this is the candle part. Okay, so this is an object. I will name it as AB. AB is an object kept at a certain distance u, and all the distances can be marked. Later on we will mark it. In order to trace the image of this object, see, you have to place sufficient space. Don't draw a very small diagram and try to incorporate everything in that. Take enough space. Take a rough paper and draw the diagram. Scribble it. You need not take all the scales and all. Draw it using your hands. That's enough. This is only learning part. In the examination you can draw it beautifully. Okay. Keep an object away from the center. Now in order to trace the image, we will take one part of the object. You need not consider all the parts of the object. Take the flame part. In the image, if you can trace where the flame is, and remaining part of the candle will be traced easily. Take one point of the candle or object. Consider some rays. It is like you are starting from, or you are studying in a class, and your friends are together. You share so many things with them. You will have very good moments and very happy moments. And with all those memories, you leave the college and go anywhere, right? It is like you are going out of the college after your studies. It is as if rays are moving out of an object. They move in different directions. They move away, they diverge. Will they meet? Concave mirror gives an opportunity for all these rays to meet again. Suppose you happen to meet somewhere in a city or so. Suppose by chance you and your friend after 10 years start working in the same company. You happen to meet, right? You meet with your friend. The first thing that you do is you will recall the memories that you had in your school days. Same thing happens here. 2 friends or 3 friends starting from A. Let us trace them. One friend starting from A and moving parallel to the principal axis. You know what happens to this boy or a girl who is studying in the school, and he has left the school and he is moving, and his journey, life is in a journey now, and it is moving parallel to the principal axis. After reflection, it passes through focus. You know this? You know this very firmly that it should pass through the focus. One ray. So one friend has moved. What happened to the second friend? Everybody is having their own journey, their own life. All of us don't go in the same direction. All of us don't do the same job. We go in different directions. Okay, so, and while drawing the diagrams, another careful thing is you should take very care is drawing arrows. If you don't draw arrows, you will lose 1 mark in a bulk, right? In physics, marks are given in the form of quantas and marks are reduced in the form of quantas. We don't reduce marks in the form of half, fraction or so, a quarter or so. We reduce it in 1 mark. Suppose there is 1 arrow is not seen, we reduce 1 mark. So better you draw the arrows, because for cheap you will lose more marks. So 1 arrow here, after reflection another arrow. Of course you can write an arrow here also if needed, but 1 arrow is enough. So a ray of light moving parallel to the principal axis, after reflection passes to the focus. Now let me take another ray which is passing through the center. You know that any ray passing through the center is incident normally to the mirror, because any ray which is towards the curvature, towards the center of the curvature is normal to the curvature. So it should get reflected back in the same path but in the opposite direction. So how should I trace the ray which is passing through the center? So another student of the same class has moved in this direction and he has incident on the mirror normally. So one ray hitting the mirror and reflected back in the same path, because this is normal incident. As if we incident a ray of light normally on a plane mirror and it getting reflected back like this, I0, R0. In the same way, this is incident and reflected back. Okay, so that returns back. Now, this ray started from the school and after reflection getting a job, reflected back here. This ray incident normally on the mirror, reflected back. They two meet here. After 20 years or so, you meet in the same company, you are getting excited, you talk to each other, you remember whatever you have done in your school days, good memories. The rays coming from here, top of the object, the flame part of the candle, they carry information from the top of the candle, flame, and they have their information now in their pocket. When they meet back, they will retrace or memorize that information here. That means here you see the candle, the flame part of the candle here. So that means, what about the rest part of the candle here? It will be like this here. So this is the image. You will see the image here. Now, so the rays of light which are starting from A, one point of the object, moving in different directions, after reflection they meet here and produce the A part of this object, and this is the image part. I will call it as A dash and I will call it as B dash. A dash, B dash is the image. See how is the image? Image is reduced, inverted, and it is real. Why do you call it as real, sir? Because rays of light are really meeting here, right? You really met your friend and you are really recalling the things. And so this is the inverted real image formed. And you see here, when the object is beyond the center, image is formed between F and C, focus and center, diminished, real and inverted. Okay. Now, can I, sir, only 2 rays start from A? No. Many rays start from A. Sir, why did you consider only 2? 2 is enough for us to trace the image. So if somebody is talking about their old school, 2 friends are enough. If there are 3 friends, okay, no problem. They will also talk to each other. So let us consider. So minimum 2 rays are enough for tracing the image. For the derivation purpose, I will consider one more ray. That is incident on the pole at some angle. So I will take one more ray incident on the pole at some angle like this. After reflection, it should pass in such a way that angle of incidence is this one, because this is normal, because it passes to the center. This is normal and it should get reflected. Of course, I choose this ray at the end because it should pass here also. It should pass here because all the rays should produce the image here only. So I will take it like this, like this. So this is the reflected ray, right? It reflects back like this. So I have chosen 3 rays. One ray parallel to the principal axis, after reflection passes through the focus. Here is the focus. And another ray passing through the center gets reflected back, but in the opposite direction, in the same path. Another ray incident towards the pole, after reflection passes and with the same angle of reflection, and it passes to the same point. So these 3 rays I must draw. Hope you are drawing along with me. That gives a lot of confidence to you, because you shouldn't listen to me at a stretch and try to draw the diagram later on. That doesn't help you at all. I give enough time to draw this, so listen at one end and keep on drawing at the other end. Hope you are doing so. So these 3 rays. So the diagram should be so legible and so clear that it shouldn't appear like somebody have cancelled it. You have so many rays of light. It shouldn't appear like somebody have cancelled it. It should appear very beautiful. Okay? Okay now. Yes. What else we can write? I will write this as M. Here, the point where the rays hit the mirror. Now, I can take MP as almost a straight line. When you have a curvature like this, if I take this M here, of course this is a curve. When you take a larger curvature, this can be taken as almost a straight line, right? That normal is a straight line. So I don't consider another normal here. MP itself is normal when the ray of light is very close to the principal axis. Okay, this is a paraxial ray parallel. Right, now we have to get this answer, right? Let us try to recognize where is focal length, where is object distance, and where is image distance. From pole here to the focus, focal length, right? You keep on writing this. From center to the pole, all distances are measured from the pole. This is a radius. All the distances are measured from the pole along the principal axis. So from pole to the focus, focal length. From pole to the center, radius. It is the center of curvature. Where is object distance and image distance? This is the object, so this is object distance, right, from the pole. Where is the image distance? V? V stands for image distance, and image distance is here, because this is the image. I will mark it with a different color so that it is visible. So this is V. V here, right? So object distance, image distance, focal length, radius, and okay, everything is over. Now we had some sign conventions earlier. All distances are measured from the pole along the principal axis. We did it. And distances measured along the direction of light are taken positive. How is the ray of light moving now? Before reflection, coming from the object here, AB, ray of light is moving in this direction. Am I right? What about distances measured? Distances are all measured from the pole in this direction. So distances are measured like this, whereas the ray of light is traveling like this. Everything is negative here. Nothing comes on the other side. So always choose the ray of light along positive x-axis. Keep the mirror, lens, everything in such a way that ray of light gets an opportunity to move along x-axis. Simply divide this into 2 coordinates. Whatever you come across, in the right, whatever is coming on the right hand side, positive. Coming on the left hand side, negative. Coming up, positive. Coming down, negative. Height of the image, negative, because below the principal axis. Height of the object, positive. Every distance from the pole. Pole is the center. It is like the Majestic of Bangalore. Everything starts from Majestic. So you move away. Everything is measured from that center. It's going away. Coming like this, opposite to the direction of light, negative. Going like this, in the direction of incident light, positive. But fortunately, we don't have anything here. Everything here. So everything negative. So later on, we are going to substitute the sign conventions. U negative, R negative, F negative, V negative. Everything is in the left hand side. So very easy sign conventions. Don't get too much confused with that. Take the ray of light along the positive axis. In such a way, keep the mirror or lens. Divide it into coordinate systems. Everything on the right positive, left negative, up positive, lower negative, over. Now, don't forget that we have started a derivation where we want this one at the end. How to do that? Now, if you want to get this F, U, V, R and everything, what you have to do is, you have to take the triangles here. Go in search of the triangle. Sir, where does F come? F comes here. Now, do you get any triangle where F comes? Yes, I can directly jump into the mathematical derivation and I can finish it, but I don't want to do so. I want to explain why that derivation is running like that. What is the purpose? Because we want to get this one. Focal length comes in this triangle. Where is radius? Radius is here, centered to P, but it doesn't come in any triangle. Okay, leave it. What about object distance? Object distance is here, that comes in this triangle. Can you see that? ABP. ABP is the triangle where BP is object distance. Okay, what about focal length? Focal length comes in FPM, this triangle. FP is the focal length. Okay, and taking those two triangles as reference where object distance and focal length comes into picture. Triangle ABP, and of course image distance comes in one picture, one triangle. What is that triangle? A', B', P. In that triangle, image distance comes into picture, right? So you go in search of all these triangles. So image distance is in A', B', P, because B', P is image distance. Object distance is in the triangle ABP, where BP is the object distance. Take those two triangles. Shall I shade that triangle a little bit with some ink or some color so that the whole diagram, of course you need not shade it. Of course for the derivation now we can shade it, but in the examination you need not shade it. I will take this triangle. Can you see this triangle here? One triangle where I can get object distance, and another triangle is this one. Another triangle where image distance appears, B', P. Now, are these similar triangles? I'm not saying equal triangles. They are similar triangles. What do you mean by similar triangles? You see, these two angles must be equal. Why, sir? This is the angle of incidence, because this is normal, this is the incident ray. This is angle of reflection. This is the normal, this is the reflected ray. So these two angles are equal. What about these two angles in the triangle? They are also equal. So I have two triangles, similar triangles, in which all the three angles are same. This angle should be equal because the third angle should be equal. Total should be 180. So this angle is, they are equal. This is angle of incidence, angle of reflection equal. So consider the similar triangles ABP and A', B', P, where you get object distance and image distance. So from similar triangles, keep on writing. You can also involve in a derivation. Don't keep as if you are watching a movie. Again I say, simply follow this. From similar triangles ABP and A', B', P. ABP and A', B', P. Hope you can follow them. And in similar triangles, always, suppose one side is double the other, then the remaining sides will also be double the other. That means the ratio of, for example, if this side of the triangle ABP is double this side, then definitely this side will be double this side. And this side will be double this side. That ratio remains the same. Suppose this one is 3 times greater than this, then this side will be 3 times greater than this. That means the ratio of AB to A', B' and AP to A', P are same. But we are in need of, this is object height, this is image height, You can clearly note it. This is image height, this is object height. Whereas this is object distance, this is image distance. But what are these things? They are nothing. So don't worry about A dash P and AP. They are not needed for us. So we will write the ratios. In similar triangles, always the ratio of corresponding sides are equal. So how larger this is AB compared to this A dash B dash, or I can write it in a reverse way. Yes, A dash B dash by AB, this is smaller and this is larger, from this triangle this side divided by this, how larger this is compared to this. In the same way, this B dash P and should be smaller, BP should be so much larger. If this is 2 times smaller than this should also be 2 times smaller than this. So ratio of corresponding sides should be same. So A dash B dash by AB, it is equal to B dash P divided by BP. Yes, that is one thing. That is one equation. Okay. Sir, is it over? No. But we were able to get B dash P and BP into picture. What is B dash P? B dash P is the image distance from B dash to pole. What is the BP? Object distance. So 2 things have come into picture, U and V. Now, take 2 similar triangles, other similar triangles. Now somehow I have to bring FP, am I right? Because focal, then this is the only thing which has not entered. In the film, object distance entry is over, image distance entry is over. Now villain has to come. Hero, heroine is finished. Villain. F. From where we will get? FP. See this triangle which contains FP. Of course, I have told M is very close to the principal axis and this is almost straight. This is 90. Now, is there any similar triangle to FMP? Yes, there is. Where is it? This triangle and similar triangle to this is here. Sir, how is these 2 similar triangles? A dash B dash F and MPF. How they are similar? Very simple. Vertically opposite angles, because this is a straight line, this is a straight line. Vertically opposite angles equal. 90 degree equal, and these angles should be equal. So from similar triangles, again, from similar triangles, A dash B dash F, A dash B dash F and MPF, A dash B dash F and MPF, what I can write? A dash B dash by MP, A dash B dash by MP, because these are the lines which are perpendicular to these adjacent sides here. So A dash B dash by MP is equal to, I need not take this because these distances are nothing in front, nothing in terms of object distance, image distance and focal length. So I need not consider this. So take this. So if A dash B dash and MP, that ratio is taken, then that must be same in accordance with the ratio B dash F by FP. Hope you have followed this. So in similar triangles, how larger this is corresponding to this, then same number of times this should be larger than this. So A dash B dash by MP must be equal to B dash F. Here is focus, B dash F by FP. Okay, this is the second equation. Okay, I will write the second equation later. Now, this MP, this is a parallel ray incident to the principal axis, parallel to the principal axis. So, what about this side, if these are parallel? MP and AB are equal. So, shall I replace MP as AB? Because this side and this side should be equal. So, A dash B dash by AB instead of this must be equal to B dash F by FP, equation 2. So a small change here, right? This you have to remember. Now see the equations 1 and 2. Left hand sides are same, A dash B dash by AB, A dash B dash by AB. So right hand side should be same. So what you will get from this one? B dash P by BP, right hand side of the first equation, same as the left hand side here, B dash F by FP. So this is the next equation from these two. So we considered similar triangles from here, this one and this one. first similar triangles where we got u and v connected. So make it like an algorithm or a flow chart. First you have to connect u and v, then you have to connect focal length from the next equation. We were able to do that. Now you can substitute b dash, okay, what is that b dash f? B dash f is, okay, what is b dash p? B dash p is image distance, bp object distance, and fp is focal length. This one, and this one have a meaning now. B dash p here, and bp object distance, image distance, focal length. But what about b dash f? B dash f is here. It is nothing. It is nothing. It is neither focal length, nor object distance, nor image distance. But one thing you can do, b dash f can be written as b dash p minus fp, where b dash p has a meaning image distance, fp has a meaning focal length. So totally b dash f can be written as this total distance minus this distance, that will give you this one. So from this total distance b dash p, if you remove fp, you will get b dash f. Because if you want to get this answer, you must be able to put all these things in u, v and f. Otherwise no use. You can put these three, but not this one. So we will exchange it now. B dash p by bp must be equal to b dash f. What is b dash f? Full length minus this one. B dash p minus fp, right? This total length minus this one, that will remain with the b dash f divided by fp, right? Now keep on substituting the values of those length. You see here, bp is only length from pole to the object, base of the object. But in terms of u, it is the object distance. You have to follow sign conventions. When you substitute the object distance, you have to follow sign convention, because object distance is not a simple distance. It is the distance from the pole to the object. But bp is only a geometrical distance. So I will substitute all the values now. B dash p is image distance, right? So when I substitute image distance, I will put minus. Minus sign is because all the distances from pole to the object, of course, even though I have written as b dash p, even though I have written it as b dash p is only a distance in the diagram. Only a distance in the diagram. But when I substitute it as image distance v, according to the sign convention, image distance is measured from the pole to the image, but when you measure it, you have to move in the direction opposite to the direction of incident light. You must write the sign convention. Minus v. bp is simply a length in the diagram, but it is equal to object distance. So if you want to replace it as object distance, you have to apply the sign convention. You have to start from the pole towards the base of the object, then you are going opposite to the incident light. Again minus u is equal to, again b dash p minus v minus of fp. F is the focus and to the pole, focal length. Of course, you have to measure it from pole to the focus. So minus f, right? Minus v, minus of minus f. All the things come in the left hand side. If you divide it into a coordinate system, everything comes in the left hand side. So v minus of minus f divided by, again fp. Fp is minus f. Pole to focus. Even though I have written it as fp, when you write focal length, it is from pole to focus. Now rearrange this. Finally try to get that one. Minus sign gets cancelled. Minus v plus f divided by minus f. Yes. V by u is equal to minus v plus f by minus f. Okay, so shall I write this? Of course, you can get it in your own mathematical way. You will finally land up with that equation. What I will do is, I will write it like this: v by u as v by u, and I will divide this f to both the numerator values. Equal to minus v by minus f, right? I will divide share this one, minus v by minus f, and this one plus f by minus f. I I'll write minus here. So minus v by minus f and plus f by minus f. This is minus 1, of course. So finally what does it mean now? V by u is equal to v by f, because minus v by minus f, and minus f by minus f, that is equal to, minus 1. This is minus 1. Right. Now divide throughout by v. If I will write 1 by 1, divide throughout by v. By v, by v, by v. On both the sides, what you will get? 1 by u, 1 by v, and once you divide it by v on the left hand side, you have to divide it by v on the right hand side also. 1 by v, 1 by f, 1 v gets cancelled, minus 1 by v, right? By v, by v, by v. So here v comes to the picture, here v gets cancelled, here v gets cancelled. Bring it to the right hand side, minus 1 by v becomes plus 1 by v. So what you will finally end up with? 1 by u plus 1 by v is equal to 1 by f. So this is the answer. So this is the relation which is connecting object distance, image distance and focal length. Okay, so this is one derivation, and along with this you may be asked to derive one more thing, what you call magnification. What do you mean by magnification? Of course, you should have a plan for this derivation. Remember, you should take the diagram in such a way that you must try to get all these things in your geometrical representation. So why do you take the similar triangles, and what similar triangles you have to take? Select the similar triangles which contain u, r, f and v. Try to get those similar triangles. Otherwise, you have plenty of triangles here. There is a lot of opportunity for getting confused. You will get confused very easily. But try to look into only those triangles which will contain all these values. Remember that you must get this finally. So try to put them in order, and finally you have to apply sign conventions and you have to get the answer. Now let me rub this. Okay, this is to be retained. I will rub this one. I'll rub this and I will get what is magnification. What do you mean by magnification? Of course, I can use the same equations for magnification. Magnification means when a mirror or a lens forms the image, how much it is magnified, how much it is diminished, we have to represent it by a term. For example, if I say, oh, that is a larger size image. How much larger? Sir, 3 times larger. If the height of the object is 5 centimeter, height of the image is 15 centimeter, then 3 is the magnification. Suppose I have an object of 10 centimeter, and if the image height is only 5 centimeter, magnification is half. That means image is half the size of the object. So magnification is defined as the ratio of the height of the image to the height of the object. Of course, in the NCERT book you have h dash by h. The ratio of height of the image to the height of the object is called magnification. For example, 10 centimeter is the height of the object. 5 centimeter is the height of the image. So 5 centimeter by 10 centimeter, you will get half. That is the meaning. Image is half the size of the object. Okay. Now how to get this? Of course, if it is asked along with this, hence obtain an expression for magnification. Not a very important derivation, but this one is important. 1 by f equal to 1 by u plus 1 by v. Suppose it is asked, you can start from where? From here, equation 2. Here only you will get this answer. You see, is this not the magnification? H dash by h? It is. Definitely it is the magnification. Yes, we will derive it from there. What is magnification? Okay. Right. A dash B dash, so from equation 2, A dash B dash by AB. What is A dash B dash? It is the height of the image. What is AB? Height of the object. But height of the image is it is below the principal axis. So when I write it, A dash B dash, I will write the equation again. Of course, this is not needed now. A dash B dash by AB is equal to B dash F by FP. I would write this now. A dash B dash, that implies, okay, H dash by H, this is minus, 1 minute, B dash P, Oh, this is not needed. I think I can use this equation. I can use this equation to get the magnification. A dash B dash by AB is equal to B dash P by BP. That gives the magnification directly. You will get this here only from the first equation. So how to get this? A dash B dash by AB is equal to B dash P by BP, and we have written it from the similar triangles ABP and A dash B dash P. Now A dash B dash, this one. So shall I write it as minus H dash? Because it is the height of the image. Minus because it is below the principal axis. AB, that is H, height of the object, H, is equal to B dash P. What is B dash P? B dash P is the distance of the image, but it is in the left hand side, minus V. And BP is the object distance, it is minus U. That is also on the left hand side. So B dash P is minus V, BP is minus U. So now this minus gets cancelled. Put it here. So H dash by H is equal to minus V by U, and that is magnification. So you can get it from the same equation. So magnification is defined as the ratio of height of the image to the height of the object, and it is also equal to the ratio of image distance by object distance, but with a negative sign. So M can be negative or positive, answer may be negative or positive sometimes, and if both object and image are above, then you may get magnification positive. So this is the formula for magnification, but this derivation is very important. So try to have a very good diagram, and according to the requirement go on for the derivation, which triangles you have to take. Suppose this is asked, tie it along with the first equation and you will get the answer. Thank you.